Welcome again, Wildcats. All right, today we're looking at Thursday, February 9th, rational function transformations. And that's going to be on page 54. All right, so if you would, pause the video and update your table of contents. All right, I assume now your table of contents are updated. So just a heads up, I'm going to be absent on Thursday and Friday. I have the great privilege of presenting a workshop at NASA's Space Exploration Educators Conference with my good old dad. So, my dad and I, correct my English if I'm correct, I always get the I's and me's mixed up, will be helping teachers launch with the catapult, Marshmallows to Mars. Okay, so it's a really big catapult. All right, so I'm going to be going on Thursday and Friday. And a little sales pitch for NASA. I don't think they use any math or science in NASA, but from my understanding, you need a math or science degree. Whoa! Oh, sorry, just fell. I don't believe you need any math or science to work there, but they require you to have a math or science degree or some sort of like that. Okay, but I recommend working there because it's a cool place. And I know because whenever I go, and I've gone the last I don't know how many years. So they let us go on VIP tours, and so this year I'm going to be going to the neutral buoyancy lab, the observation deck. Okay, they don't usually let anybody go there, but because we're teachers, we could go there. And the observation lab is basically they put the space center, the full length and size in a pool. Okay, so we actually get to walk on the floor of the pool, and you can see, you probably can put your hand in the water and touch the International Space Center that they train in. Okay, I have to tell you, NASA is probably one of the coolest places to work. So while you might never use math or science, get the degree so you can go work there. You get a lot of some super cool stuff and get to do some cool things. So with that, this video is going to be a little bit longer. It might be half an hour. I don't know, because I'm going to go through every example in the video. So if you feel like half an hour is too much to do at home, you might stop the video now and just watch the video in class. Okay. So just a heads up on that, okay? So with that, let's go into the notes. Okay, so we're going to be doing rational function transformations. Okay, so if you would, you're going to pause the video and update this. Now, it's a little hard to see, but that's actually a negative sign in front of here. Okay, so it's a negative sign. I guess I could erase a little bit there. So that's negative, and then a divided by so on, okay? So pause the video and write down the function first, and then follow along and write down the transformations, okay? So we're talking about a rational function, which is f of x equals 1 divided by, or in this case, a divided by x, okay? So when you have negative in front, so in front of this function, it reflects over the x-axis, okay? When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. All right, so when the negative is in front of the b value, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. Okay, so finish up those transformation notes. All right, now a special note, when you're working with rational functions, you have what's called asymptotes. Okay, so if you would, pause the video, open another tab, and then I want you to do some Google research, find some good math dictionaries or so on, and find out what asymptotes are. Okay, so I assume you've paused the video and you looked that up yourself, so now you know a little bit more about asymptotes. Okay, so you have in a rational function two asymptotes: a vertical asymptote, which is x equals h, and a horizontal asymptote, which is y equals k. All right, so pause the video, finish up your notes. All right, so now your notes are updated. Let's take a look at our examples. All right, so we're going to graph the rational function transformation. All right, now, when you graph these, you move the function, but you move it with the asymptotes. So you move the function with the asymptotes. Now, what I have graphed here is the parent function, okay? I have f of x equals 1 divided by x graphed, okay? Now, that parent function has asymptotes at x equals 0 and y equals 0. So while there's not a point here, we're going to put a t for the asymptotes. You're going to move this, okay? You're going to move the asymptotes when you move the transformations, okay? So we says our function's transformation is plus 2, so we're going to move the asymptote up 1, 2, okay? So our new horizontal asymptote is y equals 2, and our vertical asymptote is still x equals 0. So you're going to move the asymptotes first. That's the first thing you're going to do. Okay. Now, so we don't get confused, I'm just going to delete or erase the horizontal asymptotes. Okay. But just know that we're going to move that asymptote, the asymptotes, the horizontal and vertical, at this t whenever we move our transformations. Okay. All right. So let's go ahead and write down our asymptotes. So we have x equals 0 and y equals 2. Okay. Now, what I recommend doing is you're going to need space to find the x and y intercept. So before you do that, what you should do is go ahead and divide up your page here so you can find the x-intercepts and the y-intercepts, okay? Just a technical. So if you want to pause and then just kind of map it out so you have space. Otherwise, you're going to kind of move things. It won't look very organized, okay? All right, so we have the asymptotes, and that's the first thing you do, okay? So move the asymptotes. Now we're going to graph by direction. And if any of you out there, I think direction is just such a long word. If you have a good abbreviation for direction, let me know. All right, so to understand directions, what I want you to do is pause the video and then open a tab and graph in Desmos, okay? I think it's desmos.com, okay? So you're going to graph f of x equals 1 divided by x, and then I want you to write down the directions. All right, so I'm assuming you paused the video, you opened Desmos, you graphed it, and you realize the directions. There's only 2 good directions, which are -1, and 1, 1. Okay, so these are the directions you're going to use to move. Now, when you move the directions, you move it from the center of the asymptotes. Okay, so here, from the center, we go to the left one, down one. Okay, now, when you're graphing the line, you're going to get very close to the horizontal asymptote, but never touch, and you're going to move towards the vertical asymptote. Okay, now your next is from the center asymptotes, we go to the right one, up one, and then when you graph, you move close to the vertical asymptote and move towards the horizontal asymptote, but you never touch the asymptotes. All right, so now let's write our transformations down. Our transformation, no, there's only one, which is up 2 units. Sorry, my pencil punched the camera there. All right, so the transformation is up 2 units. All right, so now we're going to find the x, y intercepts. Now, to find the x-intercept, we know that f of x equals 0, okay? So with that, we know that 0 equals 1 divided by x plus 2. Okay, so we're going to solve for x, so we subtract 2 from both sides, so we get -2 equals 1 divided by x we know that any number is divided by 1. And we're going to do that, so now we can cross multiply. So you get negative 2x equals 1. You're going to divide negative 2 by both sides, so you get x equals negative 1/2, which we know in decimal is x equals negative 0.5. Okay, so our x-intercept is negative 0.5, comma 0. All right, so now to find the y-intercept, we know that in the y-intercept the x is 0 and that f of x equals y. Okay, so we know y equals 1 divided by 0 plus 2. Now, any number divided by 0 is undefined, which makes this undefined plus 2, which is undefined. Since the y-intercept is undefined, we know that there's no y-intercept, and we write none. Okay, so finish up example 1. All right, so now let's look at example 2. All right, so example 2, again, we're going to move. It's not really a point, it's the t, it's the center of the asymptote. We're going to move the asymptote. So in this case, it's minus 2, so we go to the right 2. So our new vertical asymptote is x equals 2, and our horizontal asymptote didn't change, so it's y equals 0. Okay, so let's go ahead and write those down. So our asymptote is x equals 2 and y equals 0. All right, and again, we need to just kind of mark out some space for our x and y intercepts. All right, so our transformation is to the right 2 units, and it reflects the x-axis. All right, so our x-intercept, we know that if it's an x-intercept, f of x equals 0. So we have 0 equals negative 1 divided by x minus 2. We know any number can be divisible by 1. And we're doing that so we can cross multiply. So 0 times x minus 2 is 0. 1 times 1 is negative 1. Since 0 does not equal negative 1, we know that there's no x-intercepts, and we write none. All right, so for the y-intercept, we know that f of x is y and x is 0, so y equals negative 1 divided by x is 0 minus 2. Now, we know that negative 1 divided by negative 2 is a 1/2, so our y-intercept is 0.5. And we write that as 0, 0.5. Really, I circled that. Really shouldn't have circled this. Just the actual y-intercept itself, because that's your y-intercept. This is just the y value of the y-intercept. All right, so finish up your x and y-intercepts. Now, you're probably thinking, Mr. Luke, you forgot something. Can you figure out what I forgot? Aha! I forgot to graph. So let's go back and graph, which is okay. All right, so we need to graph by direction. Okay. Now we know our directions are always negative 1, 1, 1. But in this case, we're multiplying the y value by negative 1. So now remember, we always move our directions from the center of the asymptote. So here we're going to go left 1, up 1. Now when you trace your line, you get close to the horizontal asymptote and move towards the vertical asymptote, but never touch. And then we go to the right 1, down 1. And again, we go close to the vertical asymptote and move towards the horizontal asymptote, but you never touch. All right, I believe that I didn't forget anything else in example 2, so finish up your graph. Now, what I'd like you to do at this point is I want you to pause the video and try example 3 and 4 on your own. Then, once you've worked them, click play and then follow along with me and see if you've done them correctly. So pause the video now. All right, so I'm assuming now that you've worked example 3 and 4. Now you're just going to check. So let's take a look. All right, so again, we're going to move our asymptotes. So in this case, we're going to the left 1, down 1, 2, 3. So our vertical asymptote is now x equals -1. And our horizontal asymptote is 1, 2, 3. At y equals -3. All right, so let's go ahead and write those down. So x equals -1, y equals -3. All right, and again, let's make space for our x and y intercept. All right, so now let's graph. All right, so again, we graph by direction. All right, so we know -1, -1, 1, 1. But in this case, we're multiplying the y value by 2. Okay, so again, whenever you move your direction, you move from the center of the asymptote intersection. So here we're going to go left 1, down 2. Again, you follow along, you move close to the vertical asymptote, and you move towards the horizontal asymptote. Okay, and then we move to the right 1, up 2. And again, you follow along the vertical asymptote and move towards the horizontal asymptote. All right, so now let's look at the transformation. So transformations are, we go left 1, we go down 3, and it's a vertical stretch by 2. All right, so now let's look and find our x and y intercepts. Now remember, if it's an x-intercept, f of x equals 0, so you set, so 0 equals 2 divided by x plus 1 minus 3. And you know what? I'm actually going to, in this problem, I'm going to steal some space from the y-intercept. All right. So that 0 equals 2 divided by x plus 1 minus 3. So we're going to add 3 to both sides. So you get 3 equals 2 divided by x plus 1. We know that we can put 3 divided by 1, so we can cross multiply. So we cross multiply, we get 3x plus 3 equals 2. Now, because we've ran out of space, we're going to do this all in one step. So we're going to subtract 3. That gives you negative 1. Divide by 3. So x equals negative 1/3. Okay, so our x-intercept is negative 1 divided by 3, comma 0. All right, so now let's look at the y-intercept. All right, so the y-intercept, we know that the f of x is y, and x is 0, so you get y equals 2 divided by 0 plus 1 minus 3. All right, so we know that 2 divided by 1 is 2, minus 3 is y equals negative 1, so our y-intercept is 0, comma, negative 1. All right, so finish up example 3. All right, so let's look at example 4. All right, so example 4. So again, we need to move the intersection of asymptotes. Okay, so we know that we're moving to the right 1, 2, 3. So our new vertical asymptote is x equals 3. And our horizontal asymptote is still y equals 0. All right, so let's go and write that down. So our asymptotes are x equals 3 and y equals 0. All right, and again, we just need some space for, I think again, I'm going to steal some space from the y-intercepts. All right, so we need a graph. So again, we're going to graph by direction. Okay, we know our directions are negative 1, negative 1, 1, 1. But here, since we're multiplying by 1/2, we need to multiply the y's by 1/2. So again, you move from the center of the intersection of asymptotes. So we go left 1, down 1/2. So it looks like it, but it doesn't. It gets very close to the horizontal asymptote, and it's moving towards, but never touches the vertical asymptote. Okay. All right, now we go to the right one, up 1/2, and we go along the vertical asymptote and towards the horizontal asymptote, but you never touch. All right, so now we have it graphed. So our transformations are to the right 3 units, and it's a vertical compression of 1/2. All right, so now let's find the x and y intercepts. All right, so again, if it's an x-intercept, the f of x is 0, so you get 0 equals 1 divided by 2 times x minus 3. We put the 0 divided by 1, so we can cross multiply. So 0 times this is 0, 1 times 1 is 1. You see that 0 does not equal 1, so there are no x-intercepts, so we write none. All right, so now let's find the y-intercept. Now, if it's a y-intercept, the f of x is y and x is 0, so y equals 1 divided by 2 times 0 minus 3, which we know is y equals 1 divided by negative 6. So our y-intercept is 0, comma, negative 1 divided by 6. All right, so look at that. We're going to make 25 minutes, not 30. Saved you 5 minutes of your life. Spend it wisely and play Xbox Live. All right, so with that, have a blue lid of a Wildcat day.